He's got a really, really cool talk coming up. So we have Johnny from Involved IT is going to be talking about how to control your home sauna using .NET 5. So Johnny, welcome in. How are you?
Hi, I'm good. I'm
Now,
great. How are you?
before you go into your talk, I have a question for you. Is
Okay.
this specifically and only for home saunas, or are other types of home applications included in your talk?
No, this is specifically for the sauna in my home.
Wow. All right. So once we're done with this talk, I'm assuming everyone has to come to your house and try out the sauna and make sure that everything you're saying is right, is correct. Yeah, you're allowed to have parties at your house now, right?
Yeah, COVID times really make it hard
A
to invite
hundred
a lot
percent.
of
Well, I'll
people.
leave everyone with you, Johnny. Again, please put in all your questions. #.NetConf. I'll keep them coming through. And over to you, Johnny. Feel free to share your stream, and away you go.
Okay, hi, welcome to .NET Conf, everyone. So I'm very excited, and I'm also very excited for .NET 5 finally releasing during this .NET Conf conference. So as you heard before, indeed, I'm going to talk a little bit about how I used the .NET 5 to go and control my home sauna. So what's the story? So first, a little bit more about me. So I work for a consultancy company called Involved, which is located in Belgium. I'm located in Belgium. Um, I'm a .NET software developer, architect. I do mostly backend development, C# and .NET, but also at home, I really like to use .NET for everything. I've been using .NET since it came out, basically in 2002. I've been using it professionally since 2008. So I'm really excited about the whole new direction that .NET 5 is heading. So basically, somewhere last year, my wife decided that maybe it's cool if we have a sauna at home. So we decided to get someone to build a sauna in our backyard. And so it's a European backyard, and you can see here it's quite small, but still we like to relax a little bit. So the big gray box is basically the sauna. Um, and inside of the sauna, there's a little control panel. So on the left-hand side, you can see a control panel. And on the right-hand side, you can see the electronics box that sits on the inside wall of the house. So if I go back to the outside view, I don't know if you know this kind of houses, but we live in what's called a bel étage. So we live on the first floor, and the ground floor is basically the garage, and all the stuff that I don't have space for is somewhere stuffed on the ground floor. So when I use my control panel to set a target temperature, and I go back inside of the living room, I'm at the first level of the house, and I'm too lazy to go outside to look. Has it already reached the target temperature? So yeah, I decided to open up the electronics box with a multimeter and check how everything basically works. Also, the control panel on the left-hand side that sits inside of the sauna, it works. It's perfectly fine. I can do everything I want with that, but it's not remote. It's only in the sauna. If you can see this circle here, this is basically the display panel, and the display panel is an old school LCD segmented display. And yeah, we're in 2020. I don't want to see segmented LCD displays in my house. So I dug around in this electronic box on the right-hand side, and I could see that on the right-hand side in the bottom, there were two relays or two switches. The one on the right-hand side, the biggest one, is the one that basically turns on or turns off my stove, my sauna heating. A stove is something different in English, so the heating for the sauna. It's a three-phase. And then on the left from that big relay or switch is a smaller switch, and this actually switches the infrared panel. So we can choose for the Finnish sauna, where you can pour water on top of the heating device, or we can do infrared, and the sauna has infrared panels all over the walls and built inside of the benches. So you can basically have two different kinds of a sauna, an infrared sauna or a Finnish sauna. And then on the top in this circle, there's some wires coming inside of this panel, and this is basically the temperature sensor. So while measuring everything, I could see that these relays or switches are easily switched by putting 220 volts on them, and then they will switch on. If you shut down the 220 volts, it will switch off. And then the temperature sensor, I noticed that it had like a ground wire, it had like an active wire containing 3.3 volts of power, and then it had a third wire which was yellow. So I thought that's probably some kind of data wire. So let's try to do something with that. So today, the sauna looks like this. The control panel inside of the sauna looks like this. I basically put two straps on top and the bottom of the original panel, and I just pasted an old Android tablet on top of that, and I did a little app in Xamarin. So the rest of my talk would basically be a walkthrough on how I actually managed to do this using .NET 5 and Xamarin. So the first thing I did was I decided to put a second electronic box next to the original one. And inside of this second box, I put a Raspberry Pi. So a Raspberry Pi is a very small computer. They're quite cheap. I think they're about $40 or $50 or euros. So let me show this to the camera. So this is a Raspberry Pi, a very small computer. It has these rows of pins at the side of it. So you can see all of those pins. Those are called GPIOs, or generic purpose inputs and outputs. So you can use them to actually do some electronics. And this mini computer can run Windows, it can run Linux. So I can basically run .NET applications on top of this. So I put that inside of the electronic box. I connected some wires. I have small relays, which are the small blue things you can see in the background. They switch on 3.3 volts. So basically, from the Raspberry Pi, I can send 3.3 volts into those relays, and those relays will then make 220 volts inside of the other relay, so they will actually switch. So basically, the Raspberry Pi is switching a small relay, and the small relay is switching the big relays. And then I'm also using one of those general purpose input-output ports to actually read the temperature from the data wire inside of the sensor right there. So this is a little movie of the Android app itself. So if you start up the application, you get a home screen, and the home screen shows you the sauna temperature, the outside temperature in the top corner, also the power usage, because I'm a geek, I want to see how much power is actually being used. And then in the bottom, there's two buttons to start either a finished sauna session or an infrared sauna session. Also, something cool that I decided to do this summer is when you start some music using Bluetooth from within the tablet itself. So I'm just starting, or I'm just playing some music right here. And if you go back to the application, it will show you the current track that is playing. So now I'm starting a sauna session. You can see that the UI changes a little bit. You have the remaining session time right there. So it's 1 hour and it's counting down. It's showing you the current track, it's showing you the current time. The power usage in the top says that it's about 6,000 watts of power usage. And then you can see a graph of your sauna temperature. So the target temperature is about 100 degrees Celsius, which should be about 200 or 250 degrees Fahrenheit, I think. So yeah, basically, you're now sitting inside of the sauna, or you're waiting until it reaches target temperature. You can see the temperature graph, and the session will run out after 1 hour, basically. So this is the default setting. I can change these settings. Maybe I want the session to take 2 hours or even longer. And then after the hour, it will automatically switch off. It will switch off the relay, and you can see in the top that the power usage is back down to 500 watts. So the sauna is actually off. So this is a small thing that I wanted to add, the power usage. So if I made a bug or a mistake in my code, that I could see that the sauna was still turned on, even if the app says it was off. So that's why it's there. So let's talk a bit about the architecture before we dive into code. So yeah, I wanted to basically connect any device in this case a Raspberry Pi, to a server to fetch and provide all kinds of data. So .NET 5 provides ASP.NET Web API for this. It was a part of .NET Framework, it was a part of .NET Core, and it's also available in .NET 5, so ASP.NET to create HTTP APIs. So I'm going to quickly show you the endpoints for this. So here you can see on my local network, I have an API running, and this has endpoints for configuration stuff. So from an Android app, I can change configuration things. I can change how long a sauna session should take, what the target temperature is, stuff like that. There's some logging information. There is information about the sensor, so I can actually ask the API for the current power usage, the current sauna temperature, the current outside temperature, and the current state of the sauna relays. So the power, I'm actually connecting to a different device in my home, which sits in my where the electric outlet comes in. So this is connecting to a different device. This is the temperature in the sauna is connecting to the Raspberry Pi, who will read the temperature live. The outside temperature is just using some kind of internet service to just get the outside temperature in my location. And then the sensor state also comes from the Raspberry Pi. Then there's sessions, so I can get the active session. I can get a list of all the sessions in the past. I can create a new session, or I can quick start a session. If you create a session, you should describe how long the session should take, what the target temperature is, and the quick start session is just pressing the button in the bottom of the Android app that will quickly start with default parameters like 1 hour, target temperature of 100 degrees Celsius, and so on. And I can, of course, cancel a running session. So back to the slides. So I also want to run a continuous process that is able to read live temperature and react on that. So basically, when I want to make the sauna reach a target temperature, I have to check the current temperature continuously. So I'm turning on the relay, and then I'm checking the temperature continuously. And when the temperature reaches the target temperature, I have to shut down or shut off the relay. Then when the temperature is going down again, I have to turn the sauna or the relay back on, so it can do some additional heating to keep that target temperature. So this is basically a long-running continuous process that needs to watch the temperature and it needs to switch these relays. So again, .NET 5 provides me with a template called a worker service, and a worker service is like a Windows service in .NET Framework, but a worker service is much more flexible. I can install this on a Linux machine and run it as a Linux daemon. I can install it on a Windows device as a Windows service, or I can just run it as a console application. So that's exactly what I'm doing. So I'm using this Raspberry Pi with Linux installed. This one sits in the electronic box right next to the sauna. This runs a Linux distribution specifically for Raspberry Pi, and this one runs my .NET Worker service continuously. So it continuously watches my temperature. Then I want to be able to read the temperature sensor and switch to relays. Again, .NET 5 can help me with that because .NET 5 runs everywhere. And when Microsoft told me that .NET will run everywhere, I was very excited because now I can do everything in my home by just using .NET with the tools that I know and that I very much like to use. So this Raspberry Pi is a 64-bit ARM device. So it's a different processor architecture than what a regular PC uses, but .NET 5 runs perfectly fine on that. It runs Linux and it has GPIO support, which means I can write C# code that actually uses those generic purpose input and output ports, and I can put signals on them. I can read signals from them. I can do whatever I want with them. And then finally, I wanted to use .NET to write a beautiful application on Android or iOS. I don't have any iOS devices at home. I only use Android. I had an old Android tablet, which I was not using anymore. So I thought, let's make an Xamarin Forms application because I was used to doing some WPF in the past. So I can use my XAML knowledge, hopefully inside of Xamarin, and create an Android application with, again, the tools that I know and that I love. Which worked perfectly fine. I've shown you the demo, which is completely done in Xamarin Forms. So a little overview for the architecture. So I have a database. And why do I have a database? Because I want to store the information related to sauna sessions. Basically, today I just have the Android tablet, which is this one. I have it right next to me. So this is the Android tablet that I'm using. I can put it in the sauna, and I can use the same application on my phone from my living room, from the couch, to see what is happening. But in the future, I really want to do a second Android app or an extension on this app that has more details, so I can schedule a session in the future. So I can schedule a session, for example, for tomorrow at 6 o'clock in the evening. I want to have a sauna session with a target temperature of 110 degrees Celsius. And then I expect all of this code to automatically make sure that the sauna reaches that temperature at that time. So that's the future of this application, and that's why there's a database. So I can store these sessions and I can store the temperature samples from that, so that I can also learn if the outside temperature is 10 degrees Celsius, for example, that I know that it takes about 40 minutes to reach target temperature. And then in the future, when I do a new session, that my application knows how much time it should start preparing before actually reaching that sauna temperature. Then on the top, there's my HTTP API. So this is the Swagger I've shown you with all the endpoints. And this actually is being used by the Android application. And this will use the HTTP API to get more information about the current temperature, about the current session that is running, also giving you a temperature history so it can draw the graph. And then on the left-hand side is the processor, which runs on the Raspberry Pi, and this can connect to the temperature sensor and the electronic switch. There is two-way communication. Why? Because basically the worker service also runs a gRPC server. So gRPC is a different kind of technology from Microsoft, and the only reason I added it to this project is because I wanted to play around with this. So gRPC is quite new for me. It was already available in .NET Core 3.0, and that's when I actually started to implement it right here. So basically, the worker service or the processor, the continuously running process that needs to connect to my Sauna, will pull the web API. It will basically every minute it will ask the web API, "Do you have a session for me? Do you have a session for me? Do you have a session for me?" And if the web API replies, "Yes, you have a session," the worker service will switch on the relays and so on. But I actually wanted to have live temperature reading. So if my Xamarin Forms application asks the web API for a temperature, the web API will connect to the worker service using the gRPC server to ask the temperature live. So it's not a stored value, it's really live connecting to the worker service, getting the temperatures from the temperature sensor and sending it back to the web API. So gRPC can provide this two-way communication for you. It's a little bit comparable to what WCF did in the .NET framework. Also, the ASP.NET Web API actually runs in my local home. I know there's great tools. We can use cloud environments. We can use Microsoft Azure, but I really wanted to run everything in my local environment without access from the outside world, because I don't want people from the outside world hacking into my sauna and making it run all day and all night using 6,000 watts of power. So that's why everything is located in my local network. And that's why the Docker container on my Synology NAS. So I don't have an actual running server, but I have a NAS containing some files and data. But this can also run Docker containers. .NET 5 runs perfectly fine in Docker containers. So I created this as a Docker container, which is very cool. So let's switch to some code. If I can find my Visual Studio. Where are you? Here you are. So this is a single solution containing all of the projects. So I have my API right here. I have, which runs .NET 5. I have my processor, which is my worker service running on the Raspberry Pi, which runs .NET 5. And actually, if you want to run a .NET application on a Raspberry Pi and you want to control these generic purpose input-output ports, you have this NuGet package that can help you with it. So system.device.gpio will actually give you the SDK, the API for you to communicate with those hardware features on a Raspberry Pi, which is quite cool. And then finally, we have the front end, which is Xamarin Forms project and an Android project. The Android project actually doesn't really contain any real UI code. It's just a wrapper around Xamarin Forms that allows you to deploy on top of an Android tablet or phone. So what I also like about Visual Studio is that when you're doing Xamarin development, it can really help you to do that in a fluent way. So for example, I can run this on an emulator on Android, but I have a physical tablet right here. So what you can also do is basically connect this using USB or using your local network. So I can say ADB connect to the IP address from my tablet, which is something like this. I think that's the IP address. Yes, and then Visual Studio automatically changes and it says run this on the Lenovo tablet. So if I just press play here, it will deploy the application on my Android tablet, and I can just debug while running on the actual tablet, which is cool. So I'm going to show you the result a little bit later because it takes a couple of minutes to actually do the deployment of the package on top of the tablet. So I've got the physical tablet right here. But I also have a screen sharing tool that can show you what's happening on the tablet itself, so I don't have to hold it up to the camera. Okay, so maybe I want to show you a little bit about the Raspberry Pi application. So a worker service basically runs a background service. So it's a class that derives from a background service, and you have to configure it by calling the add hosted service. So add hosted service will run a class continuously in the background. So I actually have 3 worker processes. So I have 3 things that continuously run in the background in a single application, in a single Linux daemon. So we have the configuration worker, which basically is a little worker that continuously asks the web API if the configuration has changed. So in my web API, I store configuration like what's the target temperature and stuff like that. So the Raspberry Pi will just ask for this information every 2 or 5 minutes or something. Then the session worker is a continuously running thing that just asks the web API, is there a current session? Is there a current session? Is there a current session? And when there is a current session, it will start working. So this runs, I think, every minute. So every minute it checks, is there a new session? And if there is a new session, it will start its work. And then the sample worker runs every 10 seconds. When there is an active session, it will start sending samples to the web API, so temperature samples. And these temperature sensors will really help me to build the actual graph that you see in the bottom. So while I was talking about this, I can see that the Android app has successfully launched. I am debugging right now. And a thing that really helped me out is something they called XAML hot reload. So I'm doing XAML UI work. So if I open up my Xamarin Forms application, this is the Sauna page. So this is the actual XAML page that runs the main screen. For example, I'm not happy with this blue color. I just want to see what the result is. Again, if you don't believe me, running live on the tablet. It's the same screen as you can see in the presentation. So if I change this to yellow, because why not? And I just press save on this file, it will automatically reload the application on my tablet. And now it's yellow. So you can just change your UI code while running your application and immediately see what it's going to look like. Because it takes a few minutes to actually do the deployment, this helps you save a lot of time. And I'm very happy I could do it like this because I just wanted to make the placement very nice. So you can just change the margins, change the sizes of things, just to make sure that everything looks perfect. And then when you're happy, you can stop debugging and you have the version that you really wanted. finally, before I go to the end of my presentation, I just want to show you a little bit of code inside of the processor to show you how to deal with these general purpose input-output ports. So I have my session worker, for example. So a worker just has an execute method, and inside of this execute method, you basically do an infinite while loop. The while loop will only stop when a cancellation token is requested. When cancellation is requested on a token, and this is automatically wired in from a Windows service or a Linux daemon. So on Linux, your service is running. If I ask Linux to stop the service, then Linux will basically make this cancellation token cancelled, and then my while loop will just finish its work. It will stop, and then Linux will shut down the application when it has waited for this to actually stop. So every 10 seconds, every 10 seconds, I will check for a session. So I'm getting the active session from the session client, which is talking to the web API. If it's not null, it will update the current session. So maybe something has changed inside of the session. Else, I'm going to kill the session if a session was active. If it was active, I'm just logging that the active session was killed. And if there was no active session, I didn't need to kill it. So I'm just going to log that there was no active session. So if I go a little bit deeper inside of the session service, so the session service with the update session, it will actually read the temperature from my GPIO service. So this is again a class that I've created myself, and it can ask questions like, is the sauna currently turned on? So if my active session requires there is a sauna session and my sauna is currently not on, then I'm going to check if my current temperature is lower than my temperature goal on my active session. If that is the case, I'm going to turn my sauna on. And then there's lots of these cases. So if one thing is turned on, but the temperature is not is reached its goal, then you need to turn it off or turn it on. So these are all of the different scenarios. And then if you dig a little bit deeper into the GIPO's service, you can see that you're basically opening a pin. All of those little pins on top of your Raspberry Pi have a number. So it's a lot of pins if you can see it. So right here, a lot of pins, they all have a number. So you can open or close those pins based on that number. Those numbers are also configured inside of the configuration, so inside of the database. So when I make a change, I make a connection change, I don't have to recompile my application. I can just change it in the database. And then you can write or read values on that pin. And the values that you can write is high or low. So basically you put a voltage on a wire or you take the voltage away from the wire. And the same thing with reading. If I want to read the temperature, if I want to read if a sauna is on, I'm just reading from that pin. If the value is high, the sauna is on. If the value is low, the sauna is off. So there's not a lot of code to actually make this work, and it works quite well, which I'm very excited about. So back to the slides. I have 1 minute remaining. I'm just going to quickly show you that I am running everything local, but I'm actually using Azure DevOps to do the actual deployment. So all of this code is on my GitHub page. It's on my Sauna repository. When I make a change, this gets updated, and automatically Azure DevOps will execute a pipeline which will do the build. It will build the Docker container for my API, and it will build the Android application, and it will build the processor. And then my release pipelines will actually do the deployment on my local environment. But I told you that I don't want to have access from outside. So basically what I'm doing is that I'm running an Azure Pipelines agent on my Synology NAS, which sits in my home. And this agent will actually perform the release. So this will ask Azure DevOps, do you have any work for me? And it will actually be deployed from within my own local network. So I don't need any access from the outside world, which is very cool. And with that, I'm at the end of my presentation. So again, you can see all of the code. You can use the code for whatever you want. Everything is available on my GitHub page. Here are the links, and thank you for joining.
Thank you so much for that amazing presentation. I really enjoyed it. We had lots of really cool stuff coming through the Twitter. So if you do get a chance, Johnny, just go through, have a brief look at a couple of the tweets because I have a couple of people who answered or asked some questions I know they'd love to hear the answer to. But before you go, I have one question for you, which is what are you hoping to automate next with Raspberry Pi in your house?
Well, basically everything. I have my lights, my power outlets, everything has its own kind of brand of device on there, but I already saw that I can communicate with all of them. So I want to create one integrated application that can control everything, basically.
Amazing. I like it. There's no like, agenda here. Just a whole lot needs to get automated. I absolutely love it. And we thank you so much for sharing your insights on how to operate your home sauna. And thank you so much for being with us for .NET Conf.
Thank you for having me.